Hello, everyone. It's Rolf from Waves and Positions. We're sticking to the moon theme. My last video was about the Artemis 2 mission, and just so happens I have another article about the moon and the Earth dynamics. It's pretty interesting. So this is something that's kind of cool, where you can cause a fight or a debate. Is fun fact, the dinosaurs never had a 24-hour day. So it's cool. You can Google this. So no one was there alive at that time, but we have theories on how the moon and the Earth were created. And based off of what we know, we think that when the moon was created, it was from whatever mass was Earth, another thing hit the Earth and caused part of the new mass to spooch out and become the moon. So when the Earth first formed, the moon was very close to the Earth. Just giving you a little preview. But I'm going to get into the article now. So it's pretty cool. So here we go. The title is "The Day Earth Learned to Slow Down." The moon is leaving. Our days are getting longer, and time is not what you think. Oh, sorry. I got my friend Bob here. Maybe one day I'll have a guest. But for now, Bob's good for just, relieving some stress. I'm a huge 49er fan, and he doesn't normally wear this hat. I wear it. I just put it on him today. But he does wear this Jets uniform because it's like the worst team in the NFL. So it's fun to punch. Anyways, here we go. That was the title. Here's the article. Once upon a time, a day on Earth lasted 6 hours. Not metaphorically, not poetically, 6 actual hours. Sunrise, sunset, done 4 times before dinner. The sky moved faster. The tides were violent. Imagine the oceans moving when everything's moving that fast. The sky moved faster. The tides were violent. The moon hung closer, swollen and enormous. Earth spun like a fighter in the first round, wild and hot and reckless. Now we live on a calmer planet. 24-hour days, predictable tides, a moon that looks serene instead of threatening. But that calm came at a cost, and it is still happening. The mechanism nobody feels. Earth is slowing because the moon is stealing momentum. Not maliciously, not dramatically, just physics. Tidal forces between Earth and the moon create friction. That friction drains rotational energy from the Earth and transfers it to the moon's orbit. As a result, Earth spins more slowly, days get longer, the moon drifts away, the number of days per year decreases. So right now, the moon recedes at about 3.8 centimeters per year, measured by laser reflectors left on the lunar surface. So, sorry, the people who think the moon landings were faked. The only reason we know this is because they put these reflectors on the moon, along with 50 other instruments that we still get some data from. It's kind of funny. But, those topics are brought up just because you get rewarded for clicks. So they just come up with these absurd ideas where some people know it's true and some people aren't sure. And so it just causes more clicks for the person to make money. So anyways, where was I? Right now, the moon recedes at about 3.8 centimeters per year, measured by laser reflectors left on the lunar surface. Small number, planet level consequences. So here we go. Time across deep history. Let's walk backwards. 4.5 billion years ago, Earth forms. The moon forms soon after, likely from a giant impact. Days are about 5 to 6 hours long. The moon orbits roughly 20 to 30,000 kilometers away, compared to today's 384,000 kilometers. Earth spins fast because it was born violent. And I'm using metric. I use centimeters and kilometers, even though I'm an American, because in science, that's what we use. It's only when we're driving places still that we use the, 5,280 feet mile. For some reason, we still use that one. But anyways, just if you're wondering, I'm not Canadian. I'm American. All right. Anyways, Earth spins fast because it was born violent. All right. So now we're going to fast forward 1.5 billion years. Now we're at 3 billion years ago. So 3 billion years ago, we're getting closer, a little more. Days are roughly 14 to 18 hours long. Coral growth patterns and sediment tidal layers support this estimate. So we have all this sort of idea of what could happen if you just reverse. Okay, it's moving it this way. We can reverse that, figure it out. But then we have actual evidence because coral leaves rings kind of like trees do. And we have coral from 3 billion years ago. So we can count the rings under a microscope because coral actually leaves a ring every day of the year. There's a ring. There's a tiny little ring that you have to look at with a really powerful microscope. So anyways, coral growth patterns and sediment tidal layers support this estimate. There are over 500 days per year. So we're still the same distance around the sun. We're just the Earth is spinning faster. So we have 500 days in a year. Life exists, but simple, microbial, ocean bound. Fast spin means stronger Coriolis forces, stronger weather systems, and more dynamic oceans. It's really sloshing. Okay, fast forward another billion years. I like to throw this out. I'll just throw this out really quick. If you've ever been confused when they talk about trillions, billions, and millions, the easiest way to conceptualize it is 1 million seconds is 11 days. 1 billion seconds is 31 years. So we're going from days to years. 1 trillion seconds is 31,000 years. So when someone's a millionaire and they drive a nice car, we're talking like 11 days to Elon Musk's 31,000 years. So they're not really the same. Just to let you know. Anyways, we're at 2 billion years. Days stretch towards 19 to 24 hours, around 440 to 450 days per year. The Great Oxidation Event reshapes the atmosphere. Oxygen rises, iron rusts out of the oceans. Longer days allow different temperature gradients. Climate begins to stabilize in ways complex life will later exploit. 1 billion years ago, days are near 21 hours, around 410 days per year. Subcontinents form and break apart. The tidal rhythms continue, transferring angular momentum outward. The moon is noticeably farther. All right, here we go. 500 million years ago, the Cambrian explosion, complex life surges. Days are about 21.5 to 22 hours, around 400 to 420 days per year. Coral fossils confirm this. They record daily growth bands like tree rings. More rings per year means shorter days. Life adapts to slower spins. All right, here we go. The dinosaurs. The dinosaurs existed from 250 to 65 million years ago. Days are about 23 hours long. See, told you. Dinosaurs never had a 24-hour day. Roughly 370 to 300 days per year. The moon is farther still. Tides are milder than in early Earth history. And dinosaurs never saw a 24-hour day. Can you believe that? Today, fast forward to today, 24-hour days, 365.2422 days per year. Earth's rotation continues, slowing by about 1.7 milliseconds per century on average. The number fluctuates due to core dynamics, glacial rebound, and atmospheric circulation, but the long-term trend is clear. The moon continues drifting away. We add leap seconds because of it. Civilization runs on atomic clocks, but the planet runs on tidal friction. All right, now we're going to go into the future. Now we know why Elon wants to get us to Mars and to the moon. We got about 500 million years to figure this out. Project forward, 500 million years from now. Project forward. Days will be roughly 25 hours long. There will be about 340 days per year. The moon will be thousands of kilometers farther away. Tides weaker, rotation slower, weather patterns different, biological rhythms rewritten again. If humanity is still there, it's still here, our descendants will experience a planet that turns more lazily under a more distant moon. Time will feel the same. It will not be the same. Zero to hero. Early Earth was chaos, hyperrotation, brutal tides, violent impacts. That instability forced evolution to adapt. As Earth slowed, complexity rose. Stability created opportunity. The planet matured because friction did its work. Raise the stakes. This is not trivia. Rotation rate influences climate systems, ocean mixing, atmospheric circulation, and tidal ecosystems. If the moon had formed farther away, Earth might have retained faster rotation longer. Climate could have been less stable. If the moon were much closer, tidal heating could have destabilized oceans. Our biosphere exists inside a narrow window of rotational physics. The moon leaving slowly is part of that long-term equilibrium. Remove it, and Earth becomes less stable. Ignore it, and you misunderstand how fragile planetary systems really are. Win-win lesson. Friction slows things down, and sometimes slowing down builds complexity. Earth did not weaken as it slowed, it stabilized. It allowed higher order life to emerge. The lesson is not poetic, it is mechanical. Energy transferred outward created structure inward. Turn pain into power. In physics, drag can create orbit. In life, resistance can create rhythm. Earth lost rotational speed, it gained ecological depth. The moon gained distance, Earth gained habitability. Constraints are not enemies, they are sculptors. What to do with this? Understand systems, respect long time scales, recognize that slow change shapes everything. Build with friction, not against it. Study constraints before chasing outcomes. The planet is not static. Neither are you. I mean, I remember John Wooden, the greatest coach of all time, pretty much all modern coaching probably goes back to John Wooden. And if you don't know who that is, Google it. John Wooden, Wood, E-N, Wooden. He said that you're either getting better or you're getting worse. You're never the same. Every day, make it your masterpiece, because you're either getting a little better or a little worse. And he was talking about basketball fitness, but you can transfer that to anyone in your life, anything. All right, here's a final thought. You live on a world that once spun 4 times faster than it does now. You stand on rock that has felt days rise from 6 hours to 24. The sky above you is the result of billions of years of invisible momentum exchange. That should not make you feel small. It should make you feel precise. You are here because the planet slowed at the right rate, at the right time, under the right constraints. If friction can turn chaos into stability for a planet, imagine what disciplined adjustments can do for a human life. Read this again slowly. Go to my Substack. Look up the parts you don't understand. Time is not abstract, it is mechanical. It can be studied, it can be respected. You can shape your own rotation, and you are not late. So you'll find when you read my Substacks, I pretty much tell a hidden history story. Then I try to get you to see how the story's message can be transferred into your own life. Because we all want to succeed. And my goal is that if I can get even one person to achieve their potential, I feel like this is all for a good cause. Because people are capable of so much. Don't think genetics or your current state of affairs should hold you back. You have choices and you can make yourself better. You can choose every day. And I tell you, tomorrow the sun will come up. Guarantee it. No matter how bad your day is today. Because, people have bad days now and again, but the sun will come up. And this is Raul from Waves and Positions. I'll see you on the next one.